Alright, I'm going to call this video a summary of those pesky ions because I know the ions are driving some of you crazy, and hopefully this will give you a little bit better idea about what ions are and how they work and how you can be knowledgeable about them. So to start out, I'm assuming that you know some things, like you are up to date on the previous chapters and that you also are good at making Bohr diagrams. I'm going to summarize a little bit. First off, an atom is the smallest piece of an element that has its properties. Each atom has got a center part with protons and neutrons in it. These are called the nucleus. And it has electrons moving around the outside of the nucleus. And these three things, protons, neutrons, and electrons, are called subatomic particles. And although it isn't really accurate, the Bohr model, which is the model that we're using in class, envisions the electrons circling around the nucleus like planets orbit around the sun. Protons have a positive charge, electrons have a negative charge. Atoms have the same number of positive charged protons and negatively charged electrons. So for each atom, the positives and the negative things inside of it balance each other out. This means that the overall atom has no charge. It's not positive or negative. We say that it's neutral. Let's look at a couple examples. We've got magnesium and fluorine here, and here's our Bohr diagrams. Magnesium has 12, if I counted right, it's got 12 protons in the nucleus. They're the positively charged things. Notice I don't have the neutrons there. The neutrons are important, they're just not important to this particular discussion, so I've left them out so that we're not worrying about them. And then it's got 12 negatively charged electrons. And here they are in the energy levels. As you well know, the first level can only have 2 electrons, and the layers after that, all these other energy levels, can hold up to 8. You fill one level at a time before you go to the next one. Fluorine has 9 protons and 9 electrons, so it only needs 2 energy levels. Same number of positives and negatives, same number of positives and negatives. When an atom goes through a certain change, we don't call it an atom anymore, now we call it an ion. So what is that change? The atom gains or loses electrons. Why does it do this? So that it has a full outer energy level, which is the most stable state that the atom can be in. Not too many, not too few. So let's look back at our magnesium and our fluorine, and let's see how they're going to accomplish that full outer energy level. Talk about the magnesium first. Well, it could gain 6 more electrons, and the yellow is showing where it would put those. That would make this outer energy level have 8, which would be a full outer level. Where would it get those? It would get them from another atom. Or it could lose 2, and I've got the 2 marked that it could lose. If it lost those 2 electrons, this entire energy level would disappear, and then its outer level would be full. So let's make that happen. There goes one. There goes the other one. And there goes the outside energy level. Now it has a full outer shell. Let's talk about fluorine. Fluorine could lose all 7 of those electrons, or it could just get 1. Getting 1 is a lot easier than losing 7. Just like for the magnesium to gain 6 is difficult, but to lose those 2 wasn't that bad. Where would the fluorine get that electron from? It would get it from another atom. Like, for instance, something like magnesium that wants to get rid of those electrons. So, to summarize here, the atom is going to do which requires the least amount of electrons. If the magnesium has to lose these 2 or gain 6, it's going to lose 2. If fluorine has to gain 1 or lose 7, it's going to gain 1. So now it's happened. The magnesium has lost its 2 outer shell electrons, leaving it with this level. The fluorine has gained 1, so it's filled up this level. The magnesium now has 10 electrons and 12 protons. You can count them yourself. And the fluorine now has 10 electrons and 9 protons. Now remember here that electrons have a negative charge and proteins have a positive charge. these aren't balanced out anymore. It has more positive things than it does negative things. It has 2 more positive things, so now it has a charge of +2. Fluorine has 10 negatively charged things and 9 positively, so it has more negative things, so fluorine has a charge of -1. So the question would be, what ion does magnesium form? It forms the +2 ion. What ion does fluorine form? It forms the -1 ion. Alright, now let's think about these things in their location on the periodic table. Here's magnesium. It's in group 2. And remind you, as you well know, or hopefully you all know, everything in this whole group up and down has got 2 valence electrons. Here's fluorine over here. Everything in this group has got 7 valence electrons, just like fluorine. So everything in this group, not just magnesium, is going to form a +2 ion. And everything in this group, not just fluorine, is going to form a -1 ion. That's the reason the periodic table looks this funny way, is it was made so that the elements would be in groups of elements that have a similar number of valence electrons. So we can summarize this by saying the things in this group have a +1 charge. The things in this group have a +1 here. This group is +2. This group is +3, -3, -2, -1. Everything in this group here has got a full outer shell of electrons, so these things don't form ions. They don't lose or gain electrons. They're not very reactive. They aren't reactive at all, really. They don't form ions. Finding one electron, getting rid of electron, is pretty easy. So everything in group 1 and group 17 is extremely reactive. Getting rid of 2 or finding 2 is not quite as easy. So the things in those 2 groups are pretty reactive. It's even harder to find 3 or to lose 3 or to find 3. So things in these 2 groups are even less reactive.